Good morning to one and all present here. My name is Pooja Singari, and I'm a third-year AIML student from Danan Sagar College of Engineering. And my presentation demo today will be on the virtual try-on application for the fashion industry. So let's get started. So what is a virtual try-on application? So a virtual try-on application is basically a technology that lets the users try on different products virtually, such as clothing items, accessories, or be it something like eyewear. So this basically gives the users an immersive experience, something which can be simulated to see how the products look on them in real life, and it gives them a visual feedback. So this virtual try-on application basically works by taking a user's input image and then transfers the product onto the image, so they can basically look at it in real time and see how the product looks and feels on them. And they can also see if the product is a good fit for them. And this virtual try-on application has already been integrated and adopted by the beauty industry and the fashion industry. And today's talk will specifically be focused on the fashion industry. So the model that we've implemented today leverages the power of Meta's Segment Anything model, as well as Stable Diffusion's Inpainting model. It also takes a prompt-based approach to seamlessly integrate the products onto the user's image. What is the need for a virtual try-on application? The first and foremost being the enhanced personalization. So because the user would be providing creative prompts, they can basically try on several products according to their preferences and body type. And it basically gives them a more customized shopping experience, because each and every one of us has a different complexion, different taste. So you can try a variety and a myriad of products at your whim whenever possible. So confidence in purchase decisions. So often we see that while we're online shopping or surfing the internet, we do come across certain products that we do like, but we're always hesitant to go and purchase them because we're not sure if they look good on us when we actually physically try them on. But when we're using our virtual try-on application, you can get a visual feedback way beforehand to see if the product fits your requirements, standards, if it's up to your mark, and if it's according to your dress code for your occasion that you're buying. And it also lets you take a decision as to whether or not to go ahead with purchasing the product. The third one being saving time and effort. I believe that this is the most beneficial aspect related to this product, because when you're living in a city like Bangalore, which is the world's second most congested city in the world with respect to traffic, it's not always feasible to manually go on to stores and physically try on products and then go to several other stores and actually have a comparison as to which product looks better on you. But using the virtual try-on application, you can basically use a creative prompt. You can try several products all at one go with the convenience from your own device. You can basically try on a shirt which is in red, blue, black, and also you can download the images, put them side by side, and also see which one looks the best for you, and you can go ahead with your decision. So not only saves your times and effort, but also eliminates the need for physical shopping. The fourth one being access to a wide range of products. So virtual try-on applications can offer an extensive catalog of fashion items from various brands and retailers, catered and tailored just for you. The architecture that we're going to be focusing on for today would basically be the Segment Anything model as well as the Inpaint model. So the model takes an input image. For example, over here is basically the image of a dog. And the star basically represents that the dog is basically the point of focus or the main area of interest over here. And when we pass this image onto the Segment Anything model, it basically segments it. So a segment or a semantic segmentation is basically a visual representation of the pixels, where the pixels are basically assigned a value or a color, and it corresponds to a particular category. So over here, you can see that the segment basically relates to the blue color, which basically has formed a boundary around the point of interest, which is the dog over here. So when you pass this segmented mask onto the inpainting model of a Stable Diffusion, you can take the mask as well as a user's prompt, and then basically you can see there are three different use cases, which is remove anything, fill anything, as well as replace anything. So let's just look at them in detail. So basically when you pass the mask with a prompt which basically says remove the object of interest, you basically get the environment without the object. This can basically be used in cases where where the user might upload an image, but he's at times distracted by certain objects in his environment. So at that time, he can basically remove them by taking them as the point of interest. The fill anything is basically the basic the main area of focus while we are talking about the fashion industry, because we will be segmenting a particular clothing item, be it a dress, be it a t-shirt. We'll basically segment it, and we can basically replace it with the user's prompt. So for example, over here, the mask was basically with respect to the dog, and the user's prompt was a teddy bear on a bench. So the prompt basically replaced the mask, which is the dog, with a teddy bear. So this can basically be used extensively in the fashion industry. And the third one being replace anything. This basically relates to the environment. So you can basically take the point of interest, which is the dog, and place it in another environment, which is sit on the swing. So this can be used in cases where you're actually trying, virtually trying on a product, but you want to see how it looks in different lighting, different environments. So say, for example, you're going for a school reunion party, or you're going for another formal occasion, and you have a particular dress code. So you use the virtual try-on application to get a visual feedback of how the dress looks, but you're not sure if it will fit the occasion. So you can basically take the point of interest and place it in such an environment. So you can basically see if it goes well together or not, and you can take a call on as to whether or not to go ahead with the outfit. So this is the overall view of the architecture, and that was basically used to implement the virtual try-on application. So like I had mentioned, the input is the base image, and we'll also be employing the user's click event, which basically generates a mask image of the base image. And then the user's prompt will basically be describing the subject, the object, or the environment, which are the three use cases as I had mentioned before. And they will be replacing the masked out portion. And the segmentation mask is basically specific pixels which were chosen by the user's click event. And the prompt given by the user replaces them by a realistic image by blending the required pixels. For the next, I would like to delve deeper into this.
Can you review the previous slide again? Missed some part of that.
Okay, sir, sure. So the input image is the base image, and we'll also be using the user's click event to generate a mask of the same. And then we'll also be taking the prompt from the user, which will basically be describing the subject, the object, or the environment. And it's basically used to replace the masked out portion. And a segmentation mask is basically a specific pixels which are chosen through the user's input, which in our case would be the user's click event, which is then fed into the Stable Diffusion's Inpainting model pipeline. So based on the prompt provided by the user, the SD model produces realistic images by blending the required pixels. So like I had mentioned, this was basically the base image. You basically use the user's click event to generate a mask, which is again fed into the SD pipeline along with the prompt. And then you can basically use any one of the three use cases according to your requirements. Now I'd like to delve deeper into the two deep learning models, which were fused together to implement the virtual try-on application. The first one being the SAM architecture, which basically stands for Segment Anything Model. So segmentation is the process of separating an object from its background or other objects and creating a mask that outlines its shape and boundaries. Like I had shown before, it basically masks the dog by creating a boundary and coloring it. So you can basically distinguish it from the environment. So the overall architecture, as you can see, is it basically takes an input image and it's fed into the image encoder. So the main purpose of why we're using an image encoder is to basically extract important features from the image. So these important features are then converted into a numerical representation, which is again known as the image embedding. So from the image encoder, we basically get the image embedding. And then we also have a prompt encoder. So the prompt encoder basically takes the prompt from the user and then converts it into a numerical representation, which is basically an embedding of the prompt. So right now we have two inputs, which is the image embedding as well as the prompt embedding. And these two embeddings are then fed as the input to the lightweight mask decoder. So the mask decoder basically maps the two embeddings and then generates several valid masks and also assigns them an accuracy score. So depending on the mask, which basically gives you the highest accuracy score, is basically considered the best mask for your use case.
No, so in this one, why we need a prompt? Because just say this is just semantic segmentation on the right output.
Yes,
so what is the role of the prompt in semantic segmentation?
So this model was basically released in April of 2023. And before that, Meta had not released the prompt encoder part. So right now they've released it as a new addition. It's basically used for zero-shot generalization.
Oh, so you're saying it doesn't have to have custom training for achieving segment. Yes, so that's why segment anything with help of prompt.
Yes, sir.
Okay. I see. Okay.
Yeah. So like I had said, there's an image encoder, there's a prompt encoder, and there's a mask decoder. So the image encoder basically under the hood uses a pre-trained vision transformer to generate a one-time image embeddings, which can be applied prior to prompting the model. And the prompt encoder also encodes the background points, the masks, the bounding boxes, or text into an embedding vector in real time. So we have an image embedding as well as a prompt embedding. And then a lightweight mask decoder predicts the segmentation mask based on the embeddings from both the image as well as the prompt encoders. It maps the image embedding, the prompt embedding, and then an output token to a mask is actually generated, which is basically like I had mentioned over here. Now I'd like to talk about the second model, which is basically the Stable Diffusion architecture. So in our use case, we're basically using a version of the Stable Diffusion, which is known as the Stable Diffusion Inpainting model. So the Stable Diffusion Inpainting is a latent text-to-image diffusion model, which is capable of generating photorealistic images given any text input with the extra capability of inpainting the pictures by using a mask. So I'd like to explain a few key points over here as well, which is the pixel space, latent space, forward diffusion, reverse diffusion, as well as conditioning. So pixel space. So pixel space is basically the domain where the input image is basically represented as a grid of discrete pixels. And the latent space is actually a compressed version, or you can basically say it's a space which is 48 times smaller than the pixel space. And the main reason why Stable Diffusion is able to offer us low latency and faster processing is because all the processing happens in latent space, which is 48 times smaller in size. And the main reason why the latent space comes into existence is because of something known as the manifold hypothesis. So the manifold hypothesis basically states that the high dimensional datasets, many of the high dimensional datasets actually lie along the low dimensional manifold latents, which is basically similar to something known as the nonlinear dimensionality reduction. So the main aim of using a latent space is dimensionality reduction, which is 48 times smaller in size as compared to the pixel space. And the two main processes which happen in the latent space are forward diffusion as well as reverse diffusion. So the forward diffusion basically takes the input image, passes it to the image encoder, and compresses it down to the latent space representation, where at each time step, you can see that noise is added to it till you get a characteristic noisy random tensor. And in the reverse diffusion, you can basically see that it's the reverse of the forward diffusion, where the noise is subtracted at each time step to generate the realistic realistic image. So the other process that I'd like to talk about is conditioning. So as you can see that the main point of focus over here is the noise. And we obviously need some way to control the amount of noise that we're adding or subtracting. And this is where conditioning comes into the picture, because conditioning basically uses something known as the predictor over here, which basically decides how much noise has to be subtracted at each time step to control or steer the direction of the noise to get the required generated image. I know that this is an overall view of the architecture, so I've generated more slides to give a deeper view or an explanation, so it makes more sense. So let me just explain in detail. So like I had said, the input image is encoded to the latent space. So consider this picture to be at the input image, and there's an encoder, which basically compresses the high dimensional image into a latent representation, which is 48 times smaller in size. That's the latent image representation. And in the second step, you can basically see that noise is added at each time step to the latent image representation to basically control how much noise is added. And that's basically done by denoising strength. So example, so the basically range which the denoising strength takes is from 0 to 1. So if it's closer to 0, you can basically understand that there's been no noise added, and it's basically the original image. But if it's closer to 1, you basically know that it's the maximum amount of noise that can be added so that the latent image becomes a complete random tensor. So over here, you can basically see that the image was passed to the encoder and it's compressed down to a smaller version, which is basically known as the latent representation. And at each time step, by using the denoising strength, you're basically controlling the amount of noise that has been added so that you can basically get a random tensor where the pixels cannot be told apart. In the next step, this is where the conditioning comes into picture, where there's a noise predictor, and under the hood, it's actually the unit model. So the image representation in the latent space, as well as the text prompt, are basically given as input. And the 3 dots basically represent the further processing of the text prompt. So for example, the text prompt is basically taken as an input string, and that string is basically converted into tokens. So each word is basically treated as a token, and then it's converted into a numerical representation, which is known as the embedding. So the image of the image in the latent space, as well as the prompt's embedding, is basically taken as the input to the noise predictor, and then it then gives you the predicted noise. So over here, you can see that the image as well as the text prompt after processing and basically being generated as an embedding is given as an input to the predictor. And over here, it generates the noise which has to be subtracted at each time step to get the generated image. So step 4 is basically where the reverse diffusion takes place, where the latent image and the predicted noise, which was basically the output of the noise predictor, is subtracted at each time step to get the generated image. And finally, you can basically see that the decoder is basically used to convert the compressed version, that is a latent representation of the image, back to the high dimensionality. So Inpainting is really just a particular case of image to image. Noise is added to the parts of the image you wanted to inpaint, and the amount of noise is similarly controlled by the denoising strength. So what I mean by noise is added to the parts of the image you wanted to inpaint is basically consider a scenario where you're basically given a choice on an online shopping website where a t-shirt is available in 3 different colors, say red, blue, black, and you're confused as to which one looks good on you. So you can basically add noise, so you can basically input an image where you're wearing a t-shirt, and you can basically mask out that particular t-shirt and add noise to the shirt, and you can inpaint the product, which is the blue, red, or black shirt, onto it and see which basically fits your requirements. So this is the basic overall architecture, which was basically fused to give the virtual try-on application. And now I would like to show you the demo.
That was a pretty good overview, folks. So it's a very complex algo diffusion model, but it was a really nice overview by Pooja.
So for now, the model is deployed on Gradio, but it'll be deployed on CS Hub very soon. So as you can see, I have basically given an input over here, and using the user's click event, I've basically generated a mask. So over here, I wanted to focus on the t-shirt or the shirt in general. So a mask of the shirt is generated. So this is basically the input. This is one of the input to the Stable Diffusion's Inpainting model. And I'll give it a prompt, say a red shirt with white stripes. So the latency is around 10 to 15 seconds, and this low latency again attributes to the latent space.
So above 2 images have to be given as input, right?
Yeah, what's that?
The 2 images are input. These 2 images are the input.
Actually, sir, actually when I clicked on the image, the mask gets generated. The user only has to send an input image. So I said red shirt with white stripes, but the model still has to be fine-tuned. Let me try another prompt.
So, okay, first time you did the segment anything, and second step you are doing the text prompting. Okay.
Yes, sir. So I can actually show it again. So this is actually the output. So I can delete this. So this is the input that I've given, and I can basically click on the image, and a mask would be generated.
But I thought in segment anything you have to give prompt also. So, but you didn't give prompt for the first part.
Yes, sir. So when we created the model, the prompt was not released as a part of the open source code for the SAM.
Oh, I see. Okay.
So we basically use the prompt which is given in the Stable Diffusion. So we're taking the prompt from the Stable Diffusion model, and we're generating masks from the segment anything model.
Got it.
I can basically say a white shirt. I can actually use the same blue checkered shirt, and we can basically submit it again, and you can basically see various variations of the same prompt in case you want recommendations on the same.
So if I run it 10 times, it will produce 10 different varieties of shirt, huh?
Yes, sir. That's the whole purpose of why we're using virtual try-on. It generated a different image.
So, okay, so this is one use case, but let's say I'm a fashion designer in Italy and I have my own clothing line. So overlaying that on a fake model would be a different use case. Am I right?
Yes, sir.
So this use case is generating new fashion,
Yes.
Whereas a different use case could be overlaying my existing fashion on fake models, right? So that would be a sort of different use case.
Yes, sir. So you would have to train the model on your products, so the model can generate your products given a prompt.
Okay.
So that's it from my side.
So this looks like a fashion designer. Am I right, Pooja? Strictly
Yes, sir.
speaking, this is a fashion creator or fashion designer.
Yes, sir. So the main aim for creating this product was basically to give you a general overview. For example, if you basically see certain shirts or stuff online, you can basically describe that product with your prompt, and you can basically see how it translates in real life. Because not every brand might implement this model, but you can basically use a generalized approach of this to describe the particular product and see it in real life on your image.
Now, one question. There are other people are also, but I just want to finish my question. So, if I were to use the prompt technique, which now Segment Anywhere has, what more it would have done?
Sir, I believe that the masks which are generated would be more accurate. On top of that, I think it'll segment it accurately. For example, if I say I want to only segment out a man, it'll segment out the entire man. So right now I'm basically using the click event. I wouldn't have to do that with the prompt.
What you are using? Click event, you said?
So sir, if I'm clicking on the image, I'm generating a mask. So I'm
Right.
saying if I use a prompt, I can just use a text to segment out a particular portion of the image. That's the main added advantage of the generalization of the prompt.
Okay, got it. Yeah, anybody else has questions? Vishal?
Yeah, so good presentation and demo. So I want to ask, here we are using it for fashion. Can we use it for creating e-commerce products, say handicrafts or anything like that on same model?
Yes, sir. Anything is possible because Stable Diffusion as such and Segment Anything model has been trained on an extensive data set. And it just depends on your creativity of your prompt to generate a photorealistic image. So it can be basically be used for several use cases. And that's why I said that this particular product has already been integrated in various industries. But just today's focus was on fashion industry, but it can be implemented to any industry as such.
Got it. Thank you. Thanks.
Thank you.
Okay, any other questions, folks?
Yeah, Pooja, where are you performing this experiment? Where are you training this model, please?
Sir, I haven't trained it as such. I've basically used out of the shelf model, and I've basically done it on Colab.
Thank you.
Okay, any other questions before we go to our second presenter for today? Any other questions for Pooja? Okay, so that was really nice presentation. Thank you, Pooja. Very well done.
Thank you for the opportunity.
And then we invite Mitadru Datta. Mitadru, are you ready?
Yes, sir.
So yeah, you can share your screen and
Sir, am I audible and visible now?
Yes, you are. So just introduce yourself and go for it.
So hello everyone, this is Mitadru Datta from CellStrat AI Lab and IIT Kharagpur. I am an undergraduate student. So let us just start with today's product demo. So is my complete screen visible?
Yes.
So yeah, we have our product. So first I need to talk about some general terms, some technical terms to better understand what exactly is happening and how can we add more and more control to our product. So just a second. So we will be talking about interior generation. So I have used the 1.5 HD Inpaint model, and I will be using a ControlNet model to further control it in my second phase of this product. And in the ControlNet model, we will be using the depth model. So let us just see how exactly we will do stuff here. So image inpainting, as already has been explained, is an image restoration technique to remove the unwanted objects and replace them with some other object. To perform this, we simply create a mask around the object in which we want to inpaint, and then we simply give say a stable diffusion prompt to replace that masked object with our new object. And our new object will be created by the process of normal stable diffusion algorithm. So in our product, there will be few parameters which I need to discuss it. So there we have the power to control the denoising strength. So it controls how much respect the final image should pay to the original content. So setting it to 0 changes nothing, and setting it to 1, you got an completely unrelated image. So I will advise you to set it to 0.75 first, and then we can change according to our need. So this is the function of denoising strength. So I will talk about a few parameters now, and you need to remember this parameter in order to create a good product of the interior design, which I am going to talk. So we also have the CFG scale, which is the classifier free guidance scale, it is a parameter to control how much the model should respect your prompt. So denoising strength was how much respect we should pay to the image, and this is how much respect we should pay to the prompt. So these are the various scales. So 1 means mostly ignore my prompt. 3 means be more creative. So in my experience, as far as I've done this model, so I will tell you to just keep it to 4 in the starting, or maybe if we want a good balance between the prompt and freedom, we can go on to little bit more than 7. So we will do both and just see. So I think the most appropriate value which was coming out was something like 9.5 in our product. So yeah, if we change the CFG scale to 30, it will say that strictly follow my prompt. Basically, don't change anything in particular. So there is also an option of mask content. So there will be various radio buttons which we can select. So there will be fill option, which will initialize with a highly blurred of the original image, and like the original will be kept unmodified. We can add latent noise and latent nothing. So these two options are there. The masked area should be initialized with fill, and random noise is added to the latent space. This is the function of latent noise, and latent nothing means the latent noise, except that no noise is added to the latent space. So yeah. So we have the seed also. So to make sure that every time we generate a new image, so we generally set this seed to -1. So in every run of our code, this seed will get changed if we set it to -1. There is also an option of mask blur. So during an inpainting, we want our object, specifically the background, the border line of our object should get mixed with the background surroundings, right? That's the main thing about inpainting. Otherwise, the thing will look completely unrelated. So this mask blur helps us to achieve that. So this scale helps us to decide how much we want the inpainted portion to mix with the surroundings. So if we set it to 0, it would completely separate from the background, and a high value, if we set it to a high value, then our inpainted object will get completely mixed with the surroundings. We won't be able to distinguish that. So it should be set to a value which is lower than half, I guess. So we'll just experiment with those. So inside the mask portion, we are basically doing this. So I am not explaining the detailed algorithm as such, but so we have a forward process in which we just add noise to the image, which we have already done here, and we just then we feed our noisy samples. Then we create a collection of different noisy samples, and then those collections we feed it to our unit architecture model. That models basically calculates the noise and just denoises that, and at different timestamp it does that, so that we can get a new image of by paying respect to our prompt or the initial image which we have given as input. So this is just the overall view of how a stable diffusion works. If you want to have a detailed understanding of that, you can always navigate to the CellStrat YouTube channel. So diffusion models have recently shown a remarkable performance in image generation tasks and have superseded the performance of generative adversarial networks on several tasks such as image synthesis. So yeah, you must also know that the ability of diffusion model is to preserve the semantic structure of the data, given we give some control to that. So the other thing which we are also actually applying here is ControlNet. So it is an extension to the Stable Diffusion model. So it gives an extra layer of control when it comes to image processing. So in some of our webinars, we had already introduced to ControlNet. So this is a really good application of ControlNet also. So I will first try to understand that how exactly it is playing its role here. So the main idea behind ControlNet is to use the additional input condition that tells the model exactly what to do. So the ControlNet users can control the output to further match with the original source image. So yeah.
Mitadru, even Pooja was using conditioning in the end. So was that, do you suspect was it with ControlNet or some other way of conditioning the image output?
I think that was I guess more of a normal stable diffusion. We are just giving the prompt, and in the prompt is filling the mask portion.
She mentioned conditioning, but not sure. I don't think it was ControlNet based, maybe some other way, or she wasn't actually.
Okay. So here we are going to do some more stuff, not only we will inpaint, then after inpainting we may be liking a particular architecture. Then how to generate more variants of that architecture, that we will do using ControlNet. So that is the point here. So let us just briefly understand how it exactly works. So we have these two latent variables as already explained here. So these are not the original observed variables which we feed to our neural network architecture. So we create a locked copy and a trainable copy to this, and we basically in our trainable copy we just are training our model. We are training our weights, and in the locked copy we are preserving the structure of our model. So the amount of control we want to add, we can just add it over here. So it copies the weights of the neural network blocks into a locked copy and a trainable copy. The trainable ones learns our condition, and the locked one preserves our model. So thanks to this, the training with small data set of image pairs will not actually destroy the production ready diffusion models. So yeah, and zero convolution, as you would be knowing, this is a 1+1 convolution with both the weights and biases initialized as zero. Not it might not continue to be at zero. So what exactly will happen? Let me just first tell you. Let's say we have a image of a dog. If we blindly apply stable diffusion to this, image to image stable diffusion to this, so we might get the dog to be in some other position, or maybe the dog is doing something. It would just create the artistic variants of this dog, right? But the dog might look a little different. It is looking here also, but the posture of the dog might be different, or we might not have much control over what is coming as the output, right? So using canny edge variant, you can generate an edge map of this dog. So there are some methods. There are some computer vision methods known as 8,-1 kernel or the canny edge detection method from OpenCV. You can just look at those. It helps us to generate a edge of our model. So edge map of our model. Now what it does is that I told you the neural networks has a locked copy and a trainable copy. So it is training a different variants of the dog, as well as it has logged the it has logged the exact posture of the dog also. And at the end, it is just combining those two. At the end, it is just combining those two. So this is how the exact control net is working. So and this is showing how the log copy. This is the entire log copy, and this is the entire trainable copy. So as you know, inside each of them, our normal encoder blocks are there. Unit architecture is there. Decoder blocks are there. So we have those. Yeah, and final decoder output will be obtained from here. So we have only encoder and the middle block in the conditioning, the trainable copy of our model. So in this way, the control net can reuse the SD encoder as a deep, strong, robust, and powerful backbone to learn the various diverse controls. So many evidences validate that SD encoder is an excellent backbone. So yeah, that's all. That's what you needed to understand for the how exactly control net is working. So in our product, we will be using this depth variant to generate more images. Yeah, so what the depth variant does is that it calculates the depth map of an image. So how it will calculate the depth map? So you can, in the OpenCV documentation, you can find this. It basically changes the perspective of the image, and from two different points, it just tries to calculate what can be the coordinates of the 3D image. So ignoring the x and y coordinate, it only takes the z coordinate, and the higher the value of the z coordinate, the higher the black color or the white color. Here the black color means more depth. So the higher the value of the z coordinate, the more will be the depth of the map. So this way a depth map is generated, and using this depth map, paying respect to the depth map, we can control what our SD output will look like. So the screenshot as you're seeing here is not created by me. This screenshot is taken from the official GitHub page of ControlNet. So I will be showing what I have exactly done and try to show you.
What are those blue bars on the left? There, I know they are like some kind of levers. So what? I mean, they are manually.
I will be explaining those.
Okay.
Yeah. So like this has not been done by me. So first I will show that what exactly I had, how I started to do, how I proceeded with that, and I will show you the final result in both the demo as well as this PPT also. So I just found a random image from the internet. So starting from this slide, all of the screenshot which you will see has been done by me. So in our product. So this interior, I just found a blank room image from the internet. So if you want to place a bed over here, so this, as you can see, the border line is not mixing properly. So I hadn't set the parameters properly for this model. So that's why the blurring portion was not quite accurate. And so after that,
the left one is the input image. Who created that black on the left?
This I am creating.
Oh, you had painted it like this.
Okay. There will be a brush option, as I will be showing that we have a blank room and a brush option. So the place where I want our object to be there, I will just create a mask over there.
Okay.
So this gives us freedom to choose our mask in any way we want. So I want our bed to be here, so I've created a mask here, just normal freehand drawing. Yeah, and here also the mask is created over here. And here I have to give a prompt also. That screenshot I could not capture it, so I have to scroll in the scroll bar also. That I will be showing anyways. So I had this Inpainting, so done, and I gave. I think this prompt I gave it as an interior design with maybe with chairs, tables, beds, and TVs. I get this, and in prompt, if you want the quality of the image to be better, you can just give a comma and write 4K and integrate design. These words, if you use in the prompt, then these are really helpful in generating good things, like the good outputs. And you can see as the mask blur has been set to 4 here. So yeah. So another idea is to use multiple rounds of inpainting. So suppose I from the complete blank room I got this TV placing idea, and so maybe I want some wall hanging now to my room, so I can just use another round of inpainting. So the output of the previous image, so this was the output of the previous execution. That output we feed it as input now, and over that input again we just use our another round of inpainting for the wall hanging. So here you can see the from colorful decoration, wall hanging, wall painting, design, integrate. So like this way you can like generate. So you can customize the room further, right? By using multiple rounds, we can also customize our room further. So these are some of the results which I have got. I think these are quite accurate results, as I showed you in the first image, that the bed was like mixing with the, not properly mixing with the surroundings. I think this, with respect to that, I think this is a quite accurate result, and some more good results I had obtained. So let's say now, as I was generating, I got some more good ideas.
Nice, good stuff.
Yeah, so it looks really real. So I will show you what exact parameters you need to set to get these some more designs. So as I was generating one by one, I thought that this idea of a sofa is really cool, right? This AI generated sofa, I would like to have it in my room. So let's say I can sit and watch a TV, and I can also let's say have a plate over here, right? So let's say I like this model, and so I would like to generate more designs of the same model, right? So here I can the idea which immediately comes is ControlNet. I can apply a layer of ControlNet over this with the depth model. So
No,
I will be using.
Up till now, you didn't use ControlNet for the images
No,
you showed.
Till now I didn't use
It is
ControlNet.
basic
It was
Stable
SG
Diffusion.
1.5 Inpaint model.
Okay, it was inpainting the web GUI of Stable Diffusion.
Yeah.
Okay, got it.
After this, I am using ControlNet. Let's say I want to generate more variations of the same design. Since maybe if our customer likes this design, so I can show more of them. So what you need to do is that I need to feed the ControlNet. There is a ControlNet panel in the downward. So I will show that in the panel I feed an image. Is the same image, so that the ControlNet models get to understand that in what depth surroundings is our object in, and then I had to select this depth option, so that it uses the depth map for that as the reference, and then the results are like this. So you can see the more or less the depth of the image has been conserved in every of them, and we have a lot of designs of our particular model which we wanted. So I think this would be a really good idea to combine ControlNet with also SG Inpaint models. So I went on to just do more and more. Like it was looking really cool.
Mitazro, in your research, did you find the real estate firms or design firms already using these algorithms for their work, or is still up and coming?
So like I did not verify that.
Okay.
I don't think.
Okay.
So we can generate variants of some other models also. Let's say I like this model too, so I can generate variants for that also. Yeah. So let's say I like this table, I can generate more variants of that table too. And this thing, I want to tell you one thing. You can note that the background is getting changed, right? So that shouldn't happen. So why it shouldn't happen? Because our room is something. So we want our object to be in our room exactly. So this thing also can be controlled. Like after I made this presentation, I got to know how to do that. So I will show you that. So, although the room design is not much different, so it is not much of a harm here. But like this can be controlled by setting the bar of the denoising strength. You can control that. Control the backgrounds too. So let us just quickly navigate. So
Ask away, Vishal.
So
Yeah,
any questions?
Mitadu, thanks for the presentation. I wanted to ask if we supply a picture of our room right now,
Yeah.
will it be able to create a new design, interior design
Yes,
for that?
yes.
So it will be a real picture, not graphically generated.
No, yes, real picture also, like you can just click and send. It
So
is possible.
Mitadu, we are basically talking about, sorry, Vishal, go ahead.
So here I'm seeing more of furniture design being changed, not so much of walls or the floor itself. So that's why I'm
Yeah,
asking
like
if I supply my room picture, which will have a lot of furniture and a lot of paintings on the walls and maybe a different floor design itself. So will it give a better version of it or a different version of it?
yeah, I think it should like for a particular loom we need to adjust the parameters, but I think it will give proper. Like we only need to mask out a portion where we want our new objects to be, right? And the remaining portion will be untouched. So like here the furnitures are generated in a blank room. So if
Mhm.
you notice that the walls are not getting changed, so we didn't create any mask around the walls initially.
So if I wanted to change the walls themselves, I'll have to create a mask on top of the walls, huh?
Yeah, or if you want the entire wall color to change or the entire wall design as a whole to change, you can just change the denoising strength bar. There is a denoising strength bar, so that will pay less respect to our image which we have fed.
Got it.
So if it pays less respect, we can just change the walls also that way.
So you apply less throttle, and so it will be more flexible in its creative process.
Yeah. So
Right.
we can just.
So Mitadu, external building design is also possible for, let's say, real estate firms.
Yeah,
External.
the
Of
same
course,
way.
then look at landscaping design. So there are a lot of use cases.
Yeah, a
So
lot of things are
pretty
possible.
much, folks, we are talking about massive disruption to real estate, architecture, and design industry. You can imagine the possibilities, and you can say a threat or an opportunity for every kind of designer, whether it's an architect or interior designer, a painter, right? Furniture designers. So we are talking about, you can call it a threat or an opportunity for these folks to use these technologies to make their work even more creative or be displaced by such technology. So as they say in AI word, folks who use AI will not replace human jobs. People who use AI will replace those people who don't use AI. So that's what they like to say. Okay, go ahead with Adru.
So yeah, we have this, and we will select this image to image because inpainting is possible for image to image only. And we will select the inpaint option from here. We will upload an image. So I had my image here. Let's say I'm selecting the interior. So I have this image, and let's say using this here, let's say first create an outline of our mask. So I'm drawing an approximate mask of a bed as of now. but it can fill with other things also. Now you can just increase the cursor size to fill it more quickly. And the mask blur, we should not change much. I think it should be 5, because we want some amount of blurriness, but we don't want our object to get completely mixed with the surroundings. So we should do this.
So Mitadro, this user interface is provided by ControlNet. Who created this UI?
So this UI, I copied it from, I think, a Hugging Face.
Oh, so the ControlNet guys have provided this UI to you.
Yeah.
Okay, got it.
Like, I think it was there with after SB 1.5 only it was.
So if we,
1.4.
Mitadro, if we want to launch this interface in CellStrat as a product, so we would have to copy this UI, or we should be creating our own UI?
I think we should create, or like, if I like here, what I did is that we are just cloning it from their GitHub page. So
If
I
it
have to
is
check
open
that.
source, we can use it. If it is an open
Yeah.
source license, we can use it as it is, because creating this level of GUI is quite hard. It's a big project in itself.
Yeah,
right?
yeah, that's what.
So if it is open source, we like to reuse work done already. So we could launch this as a product on CellStrat platform.
So let the height and width be same. So here are some algorithms we are using. I have tried most of them and seen that this Euler A is the best. We and also this batch count is what the number of images will be generated per batch, and this batch size is number of batches I want. So so if I set it to 2 and this is to 5, so I will get a total of 5 into 2, 10 images. And this CFG scale, according to my experiment, it was 9.5 or 10 something for best results. You can try out. And this denoising strength was a little 8.5, 0.85. And this seed should be -1, as I told you in my presentation, that seed -1 seed generates a new image every time. So I at first I will not be using the ControlNet option. ControlNet, it is none. And let us give some prompt like this. Colorful. So there are some keywords which you okay. So let us wait till it processes. So one thing, it is important that every image might not be that much relevant, and so you need to you need to generate a large number of images and then select an option. Some of the images might not even make that much sense. So let us just start.
So that also depends on how strictly you had the control set up, right?
Yeah.
What was your prompt again? What prompt did you ask for?
Colorful interior, chairs, tables, bed, 4K integrate.
So it's matching that. So it's producing chairs, tables, colorful, right?
Yeah, like sometimes it might generate
Something different.
like see, the chairs and tables are not like, the heights are not matching here.
Mm-hmm.
So like this image we need to discard it.
Mm-hmm.
This is, I think, perfect
Mm-hmm.
for that. And see it has generated nothing here. This one is, I think, nice.
Right.
Let's say we want a TV.
So the prompt engineering is also critical. How you prompt it.
Yeah, like I looked at an advanced prompt in LinkedIn, so that I will show that to you if I can now. But that prompt has something in braces like this. It was of this format, braces, and there was a colon over there, and then comma, and then again braces, and then colon, something like this. So, and there was a feature correspond at the left of a colon, and there was a value to that feature. So some things are there for prompt engineering which I'm not quite aware of. So see, the bed is like, I think it is quite accurate.
Mm-hmm.
See here, most of the images are blank also. We need to select some of them. So see, yeah, this is quite nice.
Mm-hmm.
So we have this, and let's say I like this bed, let's say, and I'm just save images. No bed. Let's say let's stop and save it. And let's delete this. I need to upload that new bed here over here, and now I am using this ControlNet option. So I am just giving the interior map of the room so that it can generate a depth map from here. Depth map. You can try out the various options. Let's say if ControlNet is more important.
So you use the output of previous SD process now to feed ControlNet.
Yeah. So let's say I want to generate various designs, keeping the approximate structure of this bed same.
Got it.
So using this, it will understand what is the depth map of the image. And I also give ControlNet is important. I think for this we don't need to use much prompt. Let's try it out.
Yeah, these techniques are amazing. We are looking at disrupting, maybe the $1 trillion design industry of the world. It's amazing what is possible.
Okay, so there's nothing much happening over here. So I need to change something. Let me increase this linear. So there are a lot of possibilities actually. There are options which I haven't explored it quite.
Yeah, in your third webinar on the SD series, you did show a lot of ControlNet.
Yeah,
ideas.
but I wasn't able to run this UI over there.
Right there, you were just showing the output only. Yeah.
That I did not do actually.
Right, right.
Samplings. So I will just verify what option did I use. Just resign. Let me increase YouTube. So again and again, it is generating us the same image.
So ControlNet needs its own text prompting.
Let me just check it out. Actually, when I generated this, I should have noted down the exact parameters which I am using for this.
Yes, yes, understood. So those control thresholds are the key
Yeah.
to the requirement. How you tweak the results. And this UI is provided by the ControlNet folks out of the box on their GitHub, right? So
Yeah.
yeah, it's pretty sophisticated UI. So quite a few control mechanisms here. So with that itself, we have to sort of understand how these work.
Yes.
There are millions of permutations possible here, right?
Yeah, but
So this is fine. We can launch this as a product, Mitadru. I'll request you work with our AWS cloud team for CellStrat Hub and launch it as a full stack product.
Yes.
So then our sales and marketing folks will take it up and start, sort of reaching out to potential design firms and real estate firms in India and abroad, and see if we can get interest. I mean, so Mitadru, another question which comes up is, can non-technical people operate these kind of UI tools like a graphic designer can operate it? They don't have to be AI scientists per se to do
Yeah,
creative.
like it is better if they understand some of the options, but like they can be trained by
Right,
some
right.
consultants who are like real, already experienced.
Like folks have learned Adobe Photoshop, Corel Draw, right? All the designers use these
Yes.
complex tools. So they have to start learning these AI-centric tools.
Yes. I must use that same method. Let us just try.
So the very specific ControlNet technique you're trying to use is depth map, because in your earlier webinar you had showed ControlNet has many, many types of options.
Yeah, we can explore others also.
This is purely depth map, preservation, right?
Yes. Okay, so it is not working now.
Yeah, that's fine. What more do we have, Mitadru?
Yeah, I think that's all.
Okay, fantastic. Friends, any questions? Okay. Yeah, so amazing stuff by both Pooja and Mitadru. And we are launching these two products under the CellStrat umbrella. And then our sales and marketing will be, tasked to sort of approach global customers around these two products. One is the fashion designer. The second one is this interior designer. And so, of course, then we'll be continuing to support these two products and grow the product roadmap more and more to make even better products from starting with these. So it will be a multi long-term activity for us now as part of our product roadmap planning. Um, awesome work. And any final questions, audience, before we close it today? So those who are not part of CellStrat community yet, reach out to us, and you can find our contact information on the meetup page. And if you like to join our community, any of our teams, do contact. Okay. So amazing session, Mitadru. Well done. And let's,
So
yeah.
Sir, I just forgot to do one thing.
Sure.
So can I share the screen? So it will take some time now. I am just saying what we need to do. So I had selected the depth option from here. I had selected the depth option from here, but our model is still an in-paint model. So here we need to go to our source code and just edit this v2 depth from false to true, and then it will work.
Understood.
And the depth thing will work.
Got it. Yeah, you are using Inpainting only for everything.
Yeah. So like the second time I should have changed it and like rerun the code again, and then it should have worked the same way I showed in the presentation.
Got it. No, with the sofa set you had shown in the PPT, so it was clear what it will do. Okay. Okay,
Yeah,
so
thanks a lot.
a great session with Adu. Wonderful work. Audience, any final comments or questions? Okay, then. So thank you all for joining, and we'll see you in our next webinars. Thank you all. Have a good day.